we have a practical black body radiation determination of Stephen constant. Here we have the simulator software. You have to install it from Google's Play Store, and its name is Puffin, Puffin. It will help you out to perform your practical. Here you notice water tank and is a reservoir, and here is a power switch, and here you notice on the right part of the panel having water temperature. It is now showing 35 degrees centigrade. Now you are having a surrounding temperature is 20 degrees centigrade, and there is a slider. Three sliders are there. One slider surrounding temperature, another slider for mass, and another slider to radius of disc. Now all the values are provided here. The surrounding temperature is 20 degree, mass disc is 5 gram, and you can move the slider from 0 to 10 gram, and you can move the surrounding temperature from minus 10 to 99 degrees centigrade, and the radius disc is 3 centimeter. It is also coming from 1 to 5. But you note here you have to measure the temperature T1, T2, T3 and T4. You will have to get the average of T1, T2 and T3, and T1 is provided here as 20 degree. You have to find T2 and T3 and T4, and if you want to, first you have to start your practical by keeping there is a written variables. Here variables is, these are the variables which will change. There is T2, T3 and T4, and first there are constant, that is mass of the disc. When you move the slider, the value can be changed. Let's say I am clicking over here, then the value can be changed. See, it is showing 5.3 to 6.4 gram. Now radius is now showing 3.3, and I am making it 2 centimeter. So whatever value you choose, accordingly it will work. But it is convenient to make it a value, standard value. So better you now give it again the value I got earlier, almost closer to that. I'm trying to reset it. Now it is showing value almost uh, the value is 6.8 gram mass of the disc, and the surrounding temperature I'm keeping it constant 20 degrees centigrade, and radius of the disc is 2 centimeter. I am trying to bringing nearby 3. Originally it was 3. I am using the slider to do it. Now it is 4.3 centimeter. So now it becomes constant. Then I show you the setup. Here is the water tank, Stephen Boltzmann apparatus. This is a water connection. This is the table under where you will be writing value for T1, T2, T3, and then you have to write down the average of TH, that is sum of T1, T2, T3 divided by 3, and then I will write the temperature of the T4 of the disc Kelvin. Now first of you move power on switch. What you find while you move it, temperature is showing 35 degree. Okay, then you see I am doing feed the disc. Then you see the values are changing unless it come to the stabilization. Time will be varying. Let it vary. Then if I stop it, it will show stop. Then what I notice, the values are changing accordingly. Then cross sectional view, I am showing T1 is 35 degrees centigrade. Now again I doing feed the disc, is already there, reset it. Then again they are coming back to the initial condition, right? So I have to select temperature from the probe. Say I am selecting T1 20 degree. If I select T2, then T2 is 20 degree. Then power on, then fill the disc, reset, see what happens. Then stop it. Now I find the value of the surrounding temperature is 20 degree, water temperature is 35 degree, and T1 is 35 degree. So you have to write down the value each time, and this is the water temperature 35 degree. They also written over here. It is 35 degree water temperature. Surrounding temperature is 20 degree. And T1 is 35 degree. Okay. So again you feed the disc. First you reset it. After that you come to T3. Now T3 is 20 degree. Then you water temperature is 20 degree. And again you power on. Then fill the disc. The value is changing. Then stop. Then what is T2? 35. What is T1? 35. What is T3? 35. What is T4? So these values are coming. Again you reset it once again. Reset. So it will coming to the 0 condition. Here showing T1 is 20 degree, right? Now you again feed the disc, power on. First you power on, then you feed the disc. Then what will happen? The temperature changing. T1 showing 35 degree. Then I am making the stop button. Stopped. Then I show what is T2. It is 35. What is T3? It is 35. What is T4? 30.72. So you notice these values are changing. If the time is more, the water will be heating more, definitely the T4 value will be changing. So now I am showing you finally. Remember that water temperature I am keeping 35 degree, surrounding temperature is 20 degree, mass of the disc is 5 gram, radius of the disc is 3 centimeter, and the radius of the disc is now coming steady because I am resetting it. So after you start your operation, you have to reset, bring them back into 0 condition. Then any one of the temperature showing, say T1 is 20 degree. Then you have to feed the disc and power on. First you power on, then you reset. Then you do what? Starting condition, then power on, then feed the disc. Power on, then power on, reset. After you reset, then cross sectional view, then power on, feed the disc. the values are changing slowly. It is make a stop. So T1 is 35, T2 is 35, T3 is 35, T4 is 31 point, T2 is changing. See, T2 now stabilized to 32.91, and it's therefore it is now showing further change, so it stop the process. So you see the value of T4 is coming to a halt, whereas T1, T2, say again, T1 35, T2 35, T3 35. They are almost same. That's why you are taking the average. There might be some variation. That's why you will take the average of that. So last time I have again practiced this problem. So you see the water temperature is 35 degree, surrounding temperature is 20 degree, mass of the dish is 5 gram. They are standing on a slider. So if you vary the surrounding temperature to any other value, you can do it. Say it would be convenient. Room temperature should not be disturbed. On radius should be fixed. Then again I am doing for the last time. Reset. Reset matlab it is showing 0 0. Then you start with T120 degree. Then feed power on. Then feed the disc started. Then you see what is the value of T4. T4 is changing with respect to heating. Now power on, matlab heating is going on. Now T4 is changing. See, T4 is now constant. Then you stop the process. You will continue until you find that T4 is giving a particular value. Then you note the value of T1 again. T1 is 35, then T2 35, T3 35. So whatever value you got, you put over here T1, T2, T3, you will write it down. Then the average value of T1 plus T2 plus T3 by 3 you will write. Then temperature of the disk T4 you are got here what T4, that is 32.91. Okay. So this you go keep on practicing by making any change you require. So every time you will be finding different values of T4 and almost T1, T2, T3 are same. Here you notice the value of T4 is also showing at 32.9 and it is also showing here almost 32.9. So value of T4 will be showing here and the time 47.18, that is 47 minutes 18 seconds. Now you learned the use of simulator software. Then I will go into a theory part. The aim of the work is determination of Stefan-Boltzmann constant sigma. Apparatus used here is heater, temperature indicator, box containing metallic hemisphere with provision for water flow through its annulus, a suitable black body which can be connected at the bottom of the metallic hemisphere. Principle: a black body is an ideal body which absorbs or emits all types of electromagnetic radiation. The term black body was first coined by the German physicist Kirchhoff during 1860s. Black body radiation is the type of the electromagnetic radiation emitted by a black body at constant temperature. The spectrum of the radiation is specific and its intensity depends only on the temperature of the black body. It was the study of this phenomenon which led to a new branch of physics called quantum mechanics that you will learn in your theory classes. According to Stefan-Boltzmann's law, formulated by the Australian physicists Stefan and Boltzmann, energy radiated per unit area per unit time by a body is given by equation R is E sigma T over 4, where R is the energy radiated per area per unit times E is the eta is the emissivity of the material of the body, sigma is the Stephan constant 5.67 in 10 to the power minus 8 watt meter minus 2 Kelvin to the power minus 4, and T is the temperature in Kelvin scale. He is the Joseph Stephen and he is the Ludwig Boltzmann. For an ideal black body, emissivity eta is considered to be 1 and equation number 1 reduces to what? R is not E sigma T to the power 4 but only sigma T to the power 4. So fourth power of T. R is proportional to fourth power of T. Now this is the block diagram of the experiment that we have done, and this is the setup I have shown you. Always done the heater and water and a hemisphere black body. So the black body is temperature T4 you measured, and now you see the value of T1, T2, T3 are almost same. We are taking the average. After heating, the value of T4 changes but they are stabilized to a particular value, and after it come back, then you stop it and then you note down, and what you will do, the steps for the work. The steps use a copper disc as an approximation to a black body disc which absorb radiation from the metallic hemisphere as shown figure 1. Let T suffix small d and T suffix small h is the steady state temperature of the copper disc and the metallic hemisphere respectively. Now according to the equation 2, the net heat transfer to the copper disc per second is del Q by del T is sigma A Th to the power 4 minus Td to the power 4 is equation number 3, where A is the area of the copper disc and del Q is QH minus QD. Now we have another equation from the thermodynamics for heat transfer. You have already seen in the simulator software, values are provided, the radius are provided. So that equation you will generate by finding the area and using the radius that was constant. Now del Q by del T is equal to mCp del T by del T, del of small capital D by del of small t, where m is the mass and Cp is the specific m is the mass of the disc and Cp is the specific heat of the copper, that is specific capacity constant pressure. Del T by del T is the change in temperature per unit time, equating the equation 3 and 4. Finally, you come across equation 5. There is sigma A within bracket small bracket T to the power 4 Th to the power 4 minus T to the power 4, that is minus T to the power small t to the power 4 is equal to mCp del T by del T, equation 5. And again you note over here, hence if you take value of C on one side, other side mCp by A T to H to the power 4 minus T to the power 4 del T by del T. This is the final equation. Now what are the application? Determination of the temperature of sun from its energy flux density, temperature of the stars other than sun and also their radius relative to the sun can be approximated by the similar means. Number 3, and finally we can find the temperatures of earth by equating the energy received from the sun and the energy transmitted by the earth under black body approximations. Now move on straightway towards the procedure. Although we have completed our tasks, but it is better to learn the procedure from the chart. Procedure for the performing real life. What you have done: remove the disc from the bottom of the hemisphere and switch on the heater and allow the water to flow through it. Allow the hemisphere to reach the steady state and note down the temperature T1, T2, T3. Feed the disc black body at the bottom of the hemisphere and note down its rise in temperature with respect to time till steady state is reached. That we have seen in the earlier case. After a certain time T4 was constant, so this switch off the time and then you got the value of the at the part of the moment the temperature T4 reaches, then stop it and time note down the time taken for reaching this level. A graph is plotted with the temperature of the disc along y axis and along the x axis is see the modified graph T along the temperature capital T y axis and small t is the time. So you can note the time, you can note the temperature, and finally you get the slope del T by del T. So the slope is del T by del T from the graph. And now how to use the simulator that I have already explained. This is the again furniture, this is the water tank, and this is the hemisphere, this is T1, T2, T3, and this is the T4, and this is based on the black body and heated, and this is the procedure already described. And what are the idea you get ultimately? Choose the reasonable value of the water temperature, and I already mentioned there the temperature was shown, surrounding temperature also it was shown, mass also shown, radius also shown, this using slider also shown. Click the power on button and wait till T1, T2, T3 reach the steady state. Note down its value. Putting T4 button, click fit the disk option. Note down T4 at the different time interval of time till it reaches steady state. Plot the temperature time graph and determine its slope del T by del T. Determine the Stefan's constant sigma using the given formula as mentioned in the theory. The observation should be noted in the table. It was also shown in the simulation software. This is 1, 2, 3, 3 types of 3 serial number. Matlab you have to take 3 readings. Then T1, T2, T3 will be noted for each observation. Finally, the average of T1, T2, T3 is TH. Then T4 is the temperature of the disk in the Kelvin. Then time T taken and steady state temperature of the disk in Kelvin TD. That means at the time when the temperature T4 was constant. This is all about the practical I have demonstrated. Thank you for your patient hearing, and you should follow all the steps correctly. And if you follow my instruction correctly, I hope you will perform the practical very correctly. And thank you for your patience hearing.